Welcome dear students to lecture 8 of module 1 of the subject control system. Even in this lecture I will be working out some more numericals. So here the question is, for the rotational system shown in figure, find the transfer function theta 2 of s by t of s. So first step, we know we have to write the equivalent mechanical diagram. Okay, so here we have two displacements, theta 1 and theta 2. So let me write it. So this is theta 1 and here it is theta 2. Now let us connect the things. So T of t, that is the torque input. So it is connected to theta 1. Always remember, torque is always connected from the node to the reference. Okay. So that we have connected here. Then we have J1, again moment of inertia, that is also connected between the node and the reference. So this is J1. Then we have I will write here in terms of J1, J2, okay, or let me name it here. Say this I'll consider J1, this will consider B1, this is K1, this will consider B2, and this will consider as B3. Later on we'll do the substitution for the values, whatever is given over there. Okay, so B1 is connected from the node to the ground, so that also will come over here, B1. Then we have B2 and K1, so they are connected between theta 1 and theta 2, so we'll connect it in the same manner. So here we have K1 and B2, then we have from theta 2 to the reference we have B3. So now we are done writing with the mechanical diagram. Next we'll draw the write the equilibrium equations. So let us write the equilibrium equations for this mechanical diagram. So first is for theta 1. So input we have t of t. Then we have j1 d square theta 1 by dt square plus b1 d theta 1 by dt plus k1 and b2 are between theta 1 and theta 2. So k1 theta 1 minus theta 2 plus b2 d theta 1 by dt minus d theta 2 by dt. This is equation 1. Coming to node theta 2, 0 equal to, there is no torque there. So theta 2 is equal to b3 d theta 2 by dt plus k1 into theta 2 minus theta 1 plus b2, again it is between two nodes. So d theta 2 by dt minus d theta 1 by dt. So we have to find the transfer function here. So now we have to apply Laplace for both the above given expressions. So T of s equal to s square j1 theta 1 of s plus s into b1 theta 1 of s plus k1 theta 1 of s minus theta 2 of s plus b2 into s into theta 1 of s minus s into theta 2 of s. This is for equation 1. Equation 2. 0 equal to s into b3 into theta 2 of s plus k1 into theta 2 of s minus theta 1 of s plus b2 into s into theta 2 of s minus s into theta 1 of s. So these are the two equations we have applied Laplace. Now we'll arrange the terms together, then we'll substitute the values for the equations. So equation 1, T of S will be equal to, we have the terms now together. Let us take theta 1 of S terms together. So theta 1 of S into J1S square plus B1S plus K1 plus B2S minus theta 2 of S into K1 plus B2S. So substituting the values, all we have 1 only. So theta 1 of S into J1 is 1 S square plus S plus 1 plus S minus theta 2 of S into 1 plus S. These values are given in the question, no? That values I am substituting. So theta 1 of S, T of S will be equal to S square plus 2S plus 1 minus theta 2 of S into S plus 1. This is equation 1. Equation 2, 0 is equal to minus theta 1 of S into B2S plus K1 plus theta 2 of S into B2S plus K1 plus B3S. So let's substituting the values, minus theta 1 of S into S plus 1 plus theta 2 of S into S plus 1 plus S. So this will become minus theta 1 of S, S plus 1 plus theta 2 of S into 2S plus 1. This is equation 2. Now considering equation 2, from equation 2, let us get theta 1 in terms of theta 2 of S. Because we need a transfer function to be theta 2 of S by T of S. So theta 1 of S will be equal to theta 2 of S into 2S plus 1 divided by S plus 1. Now this equation 3 we need to substitute in equation 1. So substituting equation 3 in 1, what do we get? T of S equal to, so 2S plus 1 divided by S plus 1 into S square plus 2S plus 1 into theta 2 of S minus theta 2 of S into S plus 1. Let us take theta 2 of S common, theta 2 of S into, and we can take the common denominator as well. So S plus 1 will be the common denominator. So this will be 2S plus 1 into S square plus 2S plus 1 minus S plus 1 the whole square. So here theta 2 of S by T of S is a transfer function. So this we get as x plus 1 the whole square divided by, S plus 1 in the denominator we have S plus 1, no, not S plus 1 the whole square, this mistake is. So here it is S plus 1 divided by this whole thing. This term will come in the denominator, so you can just multiply it up. So let me just write it, 2S plus 1 into S square plus 2S plus 1 minus S plus 1 the whole square. So let me just multiply the terms together. So this we get as 2S cube plus 4S square plus 2S plus S square plus 2S plus 1 minus S square minus 2S minus 1. So s square cancels, 2s cancels, 1 and 1 cancels. So what will remain over here is s plus 1 divided by 2s cube plus 4s square plus 2s. Further we can simplify this. I can take it as theta 2 of s by t of s equal to s plus 1. Let me take 2s common. If I take 2s common, I get s square plus 2s plus 1. And we know that s square plus 2s plus 1 is s plus 1 the whole square. This and this cancels. So what will remain? 1 by 2s into s plus 1. So theta 2 of s by t of s, this is the answer. So in this question, electrical system is given. You have to find the transfer function V naught of s by Vi of s. So V naught of s is across the inductor over here of 3 Henry. So first, let me just redraw the circuit with its Laplace equivalent. So here I have two inductors, one capacitor here, and one resistor in between. So this I can write it as 2s. It will become simpler, that is why. This you can write it in time domain and apply Laplace inverse, that is also possible. This will be 3s. This is 1 as it is, and this is Vi of s. Here we take it as I1 of s, and this let us take it as I2 of s. And here this capacitor, it is half farad, so it will become 2 by s. Okay. So it is 1 by Cs. No. So 1 by Cs will be 1 by C. 1 by C is 1 by half. So half 2 will come in the numerator and S will remain in the denominator. So 2 by S. So now let us apply KVL to both the loops. So if we consider first loop, so Vi of S will be equal to 2S into I1 of S plus 1 into I1 of S minus I2 of S. This is equation 1, and equation 2 will be, let me just separate out the terms together. So I1 of S will be 2S plus 1 minus I2 of S, equation 1. Equation 2 for loop 2, 0 is equal to I2 of S minus I1 of S into 1 plus 3s into I2 of s plus 2 by s into I2 of s. So getting these terms together, again here minus I1 of s plus I2 of s into 1 plus 3s plus 2 by s, 0. Equation 2. Then we need V naught of S. V naught, we know it is across the 3 Henry inductor. So V naught of S is equal to 3S into I2 of S. Equation 3. Now, from equation 2, what we have to do? We have to find, since we don't need I1, we need to find I1 of S in terms of I2. So I1 of S is equal to I2 of S into 1 plus 3S plus 2 by S. Substituting in equation 1. So Vi of S equal to I1 of S into 2S plus 1 minus I2 of S. This is the equation what we have. So let us substitute for I1 of S. So here 2S plus 1 into 1 plus 3S plus 2 by S minus I2 of S. So here also we have I2 of S, okay, and minus I2 of S. So now multiplying the terms together and taking this common term I2 of s here. So let me just multiply this. So this we get 2s plus 6s square plus 4 plus 1 plus 3s plus 2 by s, and this I2 of s, so I get as minus 1. Minus 1 minus 1, I can cancel it out, right? So then I can get this as I2 of s is equal to 6s square plus 5s plus 4 plus 2 by s. This is Vi of s. Next, what we have to do? We know V naught of s, right? So V naught of s divided by Vi of s will be equal to 3s into I2 of s is V naught of s divided by 6s square plus 5s plus 4 plus 2 by s into I2 of s. So we get this after simplification, we get the answer as 3s. Just simplify this. 6 square plus 6s cube plus 5s square plus 4s plus this is V naught of s by Vi of s. This is the answer for the transfer function. So here you have to find the transfer function x2 of s by f of s. So first step everybody knows, we have to draw the equivalent mechanical diagram. So two nodes we have x1 and x2. So x1 here and x2 here. First let us write the force. Force is connected to the node x1. Okay, so this is f of t. Then we have k1 and v1 connected between x1 and x2. So it will come like this, k1 and v1. This is k1, this is v1, and to the node x2 we have the mass m connected and the damper b connected. So this is the equivalent mechanical diagram V2. This is notation, okay, V2. So we are done with the connections. Now let us write the equilibrium equations. So for node xt, f of t is equal to, we have v1, so dx1 by dt minus dx2 by dt plus k1 into x1 minus x2. Then for the node 2, 0 equal to m I will write first, d square x2 by dt square plus v2 dx2 by dt plus, then we'll take b1 and k1. So b1 dx2 by dt minus dx1 by dt, it is between two nodes, no, that is why, plus k1 x2 minus x1. So these are the two equations. Now next step what we have to do is we have to take the Laplace transform as we are finding the transfer function. So considering the equation 1, f of s will be equal to k1 into x1 of s minus x2 of s plus b1 into s into x1 of s minus s into x2 of s. Coming to equation 2, or we'll just rearrange this first only. So x of s, x1 of s comes together. So x1 of s comes, we get k1 plus b1s plus, yes, it is minus over here. So minus x2 of s into k1 plus b1, yes. Considering equation node 2 equation, 0 equal to s square m x2 of s plus s b3 of s b2, this is b2 of s into x2 of s plus s b1 into s into x2 of s minus s into x1 of s plus k1 into x2 of s minus x1 of s. So this is your equation 2. Let us just rearrange this as well. So after rearranging, I get minus x1 of s into b1s plus k1 plus x2 of s into s square m plus s b2 plus s b1 plus k1. So now we don't need x1, so I'll take equation 2 only. So this is equation 1 and this is equation 2. So from 2 I can get x1 of s in terms of x2 of s, x2 of s, s square m plus s b2 plus s b1 plus k1 all divided by s b1 plus k1. So this is 3. Substituting equation 3 in equation 1. So what do we get? F of s equal to x2 of s into s square m plus s v2 plus s v1 plus k1 into k1 plus b1s all divided by b1s plus k1 is x2 of s, okay, here minus whole of this minus b x2 of s into k1 plus b1 s. So this and this I can cancel out. So what we get, I can take x2 of s common. So we take s square m plus sb2 plus sb1 plus k1 minus k1 minus b1 yes. So we can cancel out k1 and k1, b1s and b1s. So now what do we need? We need x2 of s by f of s. So x2 of s by f of s will be 1 divided by s square m plus sb. This is the transfer function.